Good evening, students. Anu and Nikita, Rajishma. Good evening, Nana. Nikhil. Here. Yesterday we completed the units and dimensions and errors. Now we go to discuss about the motion in a straight line. In IPE exam, there will be 4 plus 2, 4 marks question, and there is a 2 marks question. 4 plus 2 are 1 4 marks question compulsory will be from this motion in a straight line. This is a very easiest chapter. Just we go for the just what is the concept of the chapter here. Naveen, Pavan, Nikita. Good evening, Nana. Okay, here. First of all, in this lesson, first of all, we go for the what is the displacement and what is the distance. In chapter, this is the here what is the displacement and what is the distance. Displacement and distance. What is the displacement and what is the distance? Distance. For example, if a body is moving from some A to B, the total length of the path traveled by the body, that is called the distance. Total length of the path traveled by the body, that is called the distance. What is the displacement? The shortest distance between the initial position to the final position. This is called the displacement. That is from initial to final position. Displacement is the shortest distance between initial to final position. This is about the displacement and distance. Distance is always greater than the displacement except one condition. If the particle moves along the straight line, distance is equal to the displacement. In all other conditions, distance is greater than the displacement. Here there is a distance, displacement, and what is the velocity? Here velocity V is nothing but displacement by time, or rate of change of displacement is called the velocity. Rate of change of displacement is called the velocity. Here velocity is a vector quantity and another term is the speed. Speed is a scalar quantity. Speed is a scalar quantity. Speed is nothing but distance by time. Velocity is nothing but displacement by time. Here in this motionless straight line, this is based on the kinematic equations. What are the kinematic equations? There are 4 kinematic equations. What are they? That is nothing but V is equal to U plus AT. S is equal to ut plus half at square, and displacement in t seconds. S is equal to ut plus half at square. What is the velocity after a displacement? V square minus u square is equal to 2s. Displacement in nth second is equal to formula u plus a by 2 into 2n minus 1. These are called the kinematic equations. These are called the kinematic equations. And these equations are applicable when the body moves with constant acceleration, then kinematic equations are applicable. In this lesson, mainly problems and questions are based on these kinematic equations. Sandeep, is paper pattern same only now? Paper pattern is same, but in 4 marks and 8 marks there are the choice. Some more choice in the 4 and 8 marks. In 2 marks there are no choice. Okay. Next. Here this is the. And after that here problems based on these formulas, and there is a freely falling body and vertically projected body. We are discussed in this class. We are discussed on the questions based on horizontal motion and vertical motion. Horizontal motion and vertical motion. Here first of all we go for the some of the questions. How is the average velocity different from the instantaneous velocity? How is the average velocity different from the instantaneous velocity? Here, average velocity is nothing but total displacement by total time taken. This is called the average velocity. The average velocity is the ratio of the total displacement traveled by the body to the total time taken by the body. That is called the average velocity. That is called the average velocity. Here, what is the instantaneous velocity? Velocity at a particular instant of time. Velocity at a particular instant of time. That is called the instantaneous velocity. V is equal, that is nothing but ds by dt. The displacement is differentiated with respect to the time. That is called the instantaneous velocity. The average velocity is the total displacement by total time. That is called the average velocity. Instantaneous velocity is the velocity at a particular instant of time. That is called the instantaneous velocity. Here, average velocity and instantaneous velocity in uniform motion. What is the uniform motion? Body moves with constant velocity. Then that is called the uniform motion. In uniform motion, average velocity is equal to the instantaneous velocity. Here, what is the average velocity definition? When you write the exam, first we write the definitions. What is the definition of average velocity? Here, average velocity definition, average velocity. Here, what is the average velocity? That is the ratio of total displacement of the body to the total time taken by the body is called average velocity. What is the definition of average velocity? The ratio of the total displacement of the body to the total time taken by the body is called the average velocity. What is the formula for average velocity? V average is equal to the total displacement S2 plus S3 by T1 plus T2 plus T3. This is called the average velocity. What is the definition of instantaneous velocity? Instantaneous velocity. Velocity at a particular instant of time. Velocity at a particular instant of time. Velocity at a particular instant of time. At a particular instant of time is called instantaneous velocity. Instantaneous velocity. So that here what is the V instantaneous is equal to the ds by dt. Velocity at a particular instant of time is called the instantaneous velocity. The average velocity is the total displacement by total effect of the velocity, that is the average velocity. At a particular instant, that is called the instantaneous velocity. In uniform motion, the average velocity is equal to the instantaneous velocity. In all other conditions, those are not equal, but in uniform motion, the average velocity is equal to the instantaneous velocity. This is about the instantaneous velocity and the average velocity. Now we go for the give an example where give an example where the velocity h1, thanks to roots that I do not see. Very good, Nana, S1. Good. Okay, and h1. Give an example where the velocity of the object is 0. but the acceleration is not here. Here, give an example where the velocity of the object is 0, but acceleration is not. For example, if a body is projected vertically upward with some initial velocity, when body is moving upward direction, when it is moving upward direction, velocity of the body gradually decreases, becomes to 0 at maximum height. Velocity at maximum height is equal to 0, but acceleration due to gravity at this position also acting vertically downward direction. So that what is the example of the velocity of the object is 0 but not acceleration? If a body is projected vertically upward at the maximum height, velocity of the body becomes to 0, but acceleration is acting vertically downward direction. Here, what is the answer? If a body, in the case of vertically projected body, in the case of vertically projected body, in the case of vertically projected body, at maximum height, velocity is 0, but acceleration due to gravity acting vertically downwards. Acceleration due to gravity acting vertically downwards. So that in the case if a body is projected vertically upwards, or in the case of the vertically projected body at the maximum height, velocity is 0, but acceleration is not equal to the 0, that is acting vertically downward direction. That is the okay. Next one. Here, a vehicle travels half of the distance L with the speed v1 and the other half with the speed v2, then average velocity. What is the definition of average velocity? Total displacement by total time taken. Here, average velocity. V average is equal to, what is the formula? Total displacement by total time taken, that is called the average velocity. Total displacement by total time taken, that is called the average velocity. Here this is the total distance. This is nothing but total distance is nothing but L. Here first half of the distance with a velocity v1, second half of the distance with a velocity v2. Then what is the first half of the displacement, the distance with a velocity v1, second half of the distance with a velocity v2. Then what is the average velocity? The average velocity equal total displacement by total time taken. So that V average is equal to S1 plus S2 by, this is nothing but T1 plus T2. Here this L by 2 is nothing but S1 and this L by 2 is nothing but S2. S1 and S2 values are there, but there is no time T1 and T2 values. Here S1 is. And what is the T1 and T2 value? Here S is equal to, here velocity is equal to displacement by time. That implies time is equal to displacement by velocity. We are substituting in equation number 1. Equation number 1 implies average velocity is equal to S1 total displacement by T1 is equal to, what is the value? T1 is nothing but S1 by V1 plus T2 is nothing but S2 by V2. S1 by V1 plus S2 by V2. So that here V average is equal to S1 is nothing but L by 2 plus S2 is nothing but L by 2 by S1 is nothing but L by 2 into V1 plus L by 2 into V2. So that here V average is equal to L by, here L by 2 is the LCM, 1 by V1 plus 1 by V2, 1 by V1 plus 1 by V2. Here this L and L cancel, so that here V average is equal to 1 by, here what is the LCM? This is nothing but 2 into V1, V2 is the LCM. This is nothing but V2 plus V1. Therefore, 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 average velocity is nothing but 2V1, V2 by V1 plus V2. So that here, first half of the distance with a velocity V1, second half of the distance with a velocity V2, then what is the average velocity formula? 2V1, V2 by V1 plus V2. How can we solve this problem? Average velocity is equal to what is the formula? Total displacement by total time taken. Here how many displacement? Two displacements. First is the L by 2, second one is the L by 2. So that is the L by 2 in a time of V1, L by 2 in a time of V2. So that we are substituting here S1 is nothing but L by 2, S2 is nothing but L by 2, T1 is nothing but S1 by V1, T2 is nothing but S2 V by 2. So that we are substituting, then we get the answer of V average is nothing but 2V1 V2 by V1 plus V2. This is about the average velocity. This is about the average velocity. Okay, next one. The states of motion and rest are related to explain. What is the rest and what is the motion? Yeah, the state of rest and motion. Motion and rest are related to explain. Here, what is the motion? The position of the body changes with respect to the surroundings and time. That is called the motion. The position of the body does not change with respect to the position and with respect to the surroundings and time. That is called the rest. Here, rest and motion are related to explain. Here, rest and motion are relative because for example, we are moving in a train or in a bus, we are moving in a bus, we are at rest position with respect to the co-passenger, we are at rest position with respect to the co-passenger, but we are in motion with respect to the person outside the bus, we are in the motion. So that at the same time, we are in the rest with respect to the bus surroundings, we are in motion with respect to the ground surroundings, so that this rest and motion are related. Rest and motion are related. Explain and here rest and motion are related because here if a person is in a moving bus, is at rest with respect to co-passenger, but he is in motion, is at rest with respect to the co-passenger, but he is in motion with respect to the person outside the bus. With respect to the person outside the bus, he is in motion, but he is at rest with respect to the co-passenger. So that here rest and motion are related terms. Explain and rest and motion are related terms because if a person is in a moving bus, he is at rest position with respect to the co-passenger, but he is in motion with respect to the person outside the bus. So that rest and motion both are relative terms. Next one. Derive the equation S is equal to ut plus half at square using graphical method. Using graphical method. Derive the equation S is equal to ut plus half at square using the graphical method. First of all, we consider that let us consider if a body starts with initial velocity u moving with uniform acceleration and acquires a velocity v in time t seconds. First of all, we consider that. Let us consider if a body. Starts with initial velocity u, moves with an acceleration, uniform acceleration a, and acquires the velocity v in time t seconds. So that first of all, we draw the graph of velocity time graph. Here in velocity time graph, here we draw the velocity time graph. Here this is the x-axis and this is nothing but y-axis. Velocity is taken along the y-axis, time is taken along the x-axis. Here, body starts with initial velocity u. So that initially it having some velocity u. After that, body moves with uniform acceleration. What is the velocity time graph for uniform acceleration? That is a straight line with positive slope. And acquires the velocity here. Here body starts with initial velocity some u and moves with uniform acceleration, that means straight line with a positive slope. And acquires a velocity u, acquires a velocity v after t seconds. After some t seconds. Now we want to find the displacement. Here, what is the displacement in velocity time graph? Displacement S is equal to area under the graph. Area under the graph gives the displacement. Slope of the graph gives the acceleration. And here slope of the graph gives the acceleration. And area under the graph gives the displacement. So that we are taking the area under the graph. Here, what is the area under the graph? Here, this is nothing but initial velocity u. Here, this is nothing but sum. This is taken as some O. This point is nothing but A, B, C, and this is nothing but some point D. So that area under the line AB, area under the line AB gives the displacement. So the displacement is nothing but area under the line AB. That is nothing but area of the triangle plus area of the rectangle. So that therefore displacement is equal to area under AB line. So that displacement is equal to area of rectangle OACD plus area of triangle ABC, area of the rectangle OACD plus area of the triangle, ABC, area of the triangle ABC. Okay, here. So that here displacement S is equal area of rectangle OACD plus area of triangle ABC, area of the triangle ABC. What is the formula for the area of the rectangle? Area of the rectangle is nothing but length into breadth plus area of the triangle is nothing but half base into height. Half base into height. So the displacement S is equal. Here this is the OACD rectangle. Here this is nothing but, here this is the U is nothing but the breadth and time is nothing but the length. So that length into breadth, that is nothing but some U into T plus half into base is nothing but time. Here in the triangle base is nothing but what the value time and height is nothing but sum, this is nothing but V minus U. Height is nothing but what the value? V minus U. So that here this is nothing but V minus U. That is nothing but accelerate here. So that S is equal to UT plus half into T into V minus U. Here since acceleration is equal V minus U by T, that implies V minus U is nothing but we are taken as AT. So that this is nothing but we are taken as AT. Therefore S is equal UT plus half AT square. Displacement is nothing but UT plus half AT. Simply. So let us consider a body starts with initial velocity U moving with uniform acceleration A and acquires a velocity V after t seconds. First of all, we consider that. Let us consider a body starts with initial velocity U moving with uniform acceleration A and acquires a velocity V in time t seconds. After that, we draw the graph, velocity time graph, starting with initial velocity U and acquires the final velocity V after t seconds. So that in velocity time graph, displacement is nothing but area under the line AB line. What is the area under the AB line? Area of the rectangle plus area of the triangle. Area of the rectangle plus area of the triangle. Area of the rectangle is nothing but length into breadth. Area of the triangle is nothing but half base into height. So that UT plus half T into height is nothing but V minus U. A is equal, we know that acceleration is nothing but V minus U by T. V minus U is represented as AT. Then we get the S is equal to UT plus half. Most important question. Here S is equal to UT plus half AT square. Derivation is the most important. Yeah, previously this question is asked. Here S is equal to UT plus half AT square. This is the derivation. Next one. Here, a particle moves rectilinearly with uniform acceleration. Its velocity at the time t is nothing but v1, and at the time t is equal to 0 is v1, at the time t is equal to t is v2. The average velocity of the particle in this time interval is nothing but v1 plus v2 by 2. The average velocity of the particle in this time interval is nothing but v1 plus v2 by 2. Is this statement is true or false? Substantiate your answer. First of all, here this is the solution. First one is here this is true. Why it is true? Average velocity is nothing but v1 plus v2 by 2. Now we go for that one. Here particle moves with uniform acceleration. When the particle moves with uniform acceleration, we can apply the kinematic equations. Here, at t is equal to 0, initial velocity is given that v1. At the time t is equal to t, final velocity is given that sum, that is nothing but v2. that is nothing but V2. So that displacement S is equal to formula ut plus of AT square is the S is equal to ut plus of AT square. S is equal U is nothing but V1T plus of into what is the acceleration of the particle, that is nothing but V minus U by T. So that acceleration is nothing but V2 minus V1 by what is the time taken T, so that acceleration is nothing but V2 minus V1 by T. So that this is the V2 minus V1 by T into this is nothing but T square. Here T square cancel. S is equal to V1T plus this is nothing but V2 into T by 2 minus V1 into T by 2. So that S is nothing but V1 into T by 2 plus V2 into T by, because V1T minus V1T by 2, that is the, so that here, so that displacement is nothing but V1 plus V2 by 2 into time. Total displacement is nothing but V1 plus V2 by 2 into time. So that displacement by time, total displacement by time, that is nothing but V1 plus V2 by 2. But total displacement by time, that is nothing but average velocity. Total displacement by time, that is nothing but average velocity. Therefore, total displacement by time is nothing but average velocity. That is nothing but V1 plus V2 by 2. So that, what is the average velocity? Here given that the velocity at t is equal to 0, velocity is nothing but V1. At t is equal to velocity is nothing but V2. Then average velocity is nothing but V1 plus V2 by 2. The statement is true and we are using the formula S is equal to ut plus of AT square. S is equal to ut plus of AT square we are using. Then A is nothing but what is the value? V2 minus V1 by T. We are substituting. Then that is nothing but S by T is nothing but V1 plus V2 by 2. S by T is nothing but total displacement by total time. That is nothing but average velocity is equal to V1 plus V2 by 2. Okay, next one. Here, can the velocity of the object be in a direction other than the direction of acceleration of the object? Explain. Here, given that, can the velocity of the object be in a direction other than the direction of the acceleration? Yes, it can possible. For example, in the case of the vertically projected body, velocity is in the upward direction, but acceleration due to gravity is acting vertically downward direction. So that velocity and accelerations are opposite direction. So that here, yes, it can be possible. For example, in the case of vertically projected body, vertically upwards projected body, velocity is in upward direction. Velocity is in upward direction, but acceleration in downwards. Acceleration is in downwards. It can possible. In the case of vertically projected body, velocity is in upward direction, but acceleration is in downward direction. So that velocity and accelerations are possible in opposite direction. So other direction of the velocity is in other direction of the acceleration, it is possible in the case of vertically projected body, and in the case of the projectile motion is also that can be possible. Okay, next one. The instantaneous speed is always equal to the magnitude of the instantaneous velocity y. Here given that instantaneous speed is always equal to the magnitude of instantaneous velocity y. What is the instantaneous speed or velocity? Here, instantaneous speed what is the instantaneous speed is nothing but the speed at a particular instant of time, that is called the instantaneous speed. V instantaneous is equal limit t tends to 0 delta x by delta t. In a small interval of time, in a fraction of the time, what is the speed at a particular instant of time, that is called the instantaneous speed. Here, what is the instantaneous velocity? Here instantaneous velocity. Here V instantaneous is equal to, here instantaneous velocity is equal in a small interval of the limit t tends to 0 delta x bar by delta t. This is called the instantaneous velocity. In a small interval of time, that is a displacement or distance are small, so the distance is equal to the displacement. So that instantaneous total displacement by time is called the average velocity. Instantaneous speed is the speed at a particular instant of time, and instantaneous velocity is the displacement velocity at a particular instant of time. In the small instant of time, fraction of the time, magnitude of the speed is equal, magnitude of distance is equal to the magnitude of the velocity displacement. Here is the, in small interval of time, in small time interval, here distance is equal to the displacement. Delta x is equal to the delta x dash. Therefore, instantaneous speed is equal to, therefore, instantaneous speed is equal to instantaneous velocity. Instantaneous velocity. For example, here in this small interval of time, displacement and distance are equal, so that instantaneous speed is equal to the instantaneous velocity. Next one. A ball is dropped from the roof of a tall building. A ball is dropped from the roof of a tall building. Simultaneously, another ball is thrown horizontally with some velocity from the same roof. Which ball lands the first? Explain your answer. Here, both will reach the ground simultaneously. Both will reach the ground simultaneously, because here both will reach the ground simultaneously, because here given that this is the top of the tower, some of height, some taken as some h. Here if a body is dropped, initial velocity is nothing but 0. Vertical initial velocity is nothing but 0. Here it is taken as some case 1. Case 1. What is the initial velocity? That is nothing but, case 1 is nothing but freely falling. So that freely falling, so that initial velocity 0. Acceleration is nothing but g. Time taken to reach the ground is nothing but t. S is nothing but h. So that if we are using the formula, S is equal to ut plus half at square. S is equal to ut plus half at square. H is equal to this, the half gt square. Therefore, t is nothing but under root of 2h by g. This is nothing but equation number 1. This is for the freely falling one. Here, next body is projected horizontally with some initial velocity u, so that due to the gravitational force It is moving parabolic path and reached the ground. Here we go for the case 2. Horizontal projectile. Horizontal projectile. In the horizontal projectile, body is projected horizontally so that vertical component of velocity, horizontal component of velocity, here horizontal projectile, here vertical component of velocity, vertical component of initial velocity. Vertical component of initial velocity uy is equal to the 0 because that is thrown horizontally. Only there is a horizontal velocity. What is the vertical velocity? That is equal to the 0. Vertical velocity is equal to the 0. So that vertical is 0. And along the vertical direction, A is nothing but plus G. What is the displacement traveled vertically H? Now we want to find the time. So that here also we are taking the S is equal to ut plus half at square, H is equal to half gt square, therefore time t is nothing but under root of 2h by g. So therefore from 1 and 2, some this is taken as some t2 time and this is taken as some t1 time. So that from 1 and 2, T1 is equal to the T2. That means the body is projected horizontally, and if a body is dropped from the same top of the tower, both will reach the ground at the same time. Both will reach the ground at the same time. Okay? Both will reach the ground at the same time. Next one. Next problem. Here, a man walks on a straight road from his home. A man walks on a straight road from his home to a market. From his home to a market 2.5 kilometers away with a speed of 5 kph. Finding that market is closed, he instantly turns and walks back to home with a speed of 7.5 kilometers per hour. What is the magnitude of average velocity and what is the magnitude of the speed within the time interval of 0 to 50 minutes? First of all, just we draw the diagram. For example, this is nothing but home. This is nothing but market. Here, first of all, he is moving from home to the market with a speed of V1 is nothing but 5 kmph, moving from home to market and moving back market to the home with a speed of 7.5 kmph. First of all, we want to find what is the average velocity. What is the average velocity? Here, first one, we go for the average velocity. Here, average velocity is equal to total displacement by total time taken. Here, what is the total displacement of the body? Here, body is moving from home to the market and from market to the home. Initial and final points are same. Initial point is home, final point is also home. So that what is the displacement? 0. Therefore, V average is equal to average velocity is equal to the 0 since displacement is equal to the 0. So average velocity is equal to the 0 because displacement is equal to 0. Second one, we go for the average speed. Average speed is nothing but total distance by total time is the average speed. Total displacement by total time is called the average velocity. Here average speed, that is also some V average is equal total distance d1 plus d2 by total time taken, that is nothing but t1 plus t2. Here total distance is nothing but, that is nothing but initial distance is nothing but 2.5 kilometer. Final distance is also the 2.5 kilometer. Distance is a scalar quantity, displacement is a vector quantity. So the displacement becomes to 0, but distance is not equal to the 0. So that, first of all, here what is the time taken, T1 and T2 values. Here D1 is equal, D2 is equal 2.5 kilometer, and here speed is equal distance by time. That implies time is equal distance by velocity. So that T1 is nothing but D1 by V1. T1 is equal, D1 is nothing but 2.5 by V1 is nothing but, what is the velocity? V1 is nothing but 5 kmph. 5. So that T1 is nothing but 0.5 hour. 0.5 hour. T1 is nothing but 0.5 hour. Or T1 is nothing but 30 minutes. T1 is nothing but, what is the value? 30 minutes. Now we go for the T2. Now we go for the T. T2 is nothing but, what is the value? D2 by V2. D2 by V2. So the T2 is equal, D2 is also nothing but 2.5 by V2 is nothing but 7.5 kmph. So that this is nothing but 3 times. T2 is nothing but 1 by 3 hour. 1 hour is equal to 60 minutes. So the T2 is equal to 1 by 3 into 60. T2 is equal to, what is the value? 20 minutes. T2 is nothing but 20 minutes and T1 is nothing but 30 minutes. Now we want to find average speed. Therefore, average speed. Average speed V average is nothing but D1 plus D2 by T1 plus T2. Here D1 and D2 in kilometer per hour. So that here this is nothing but T2 is nothing but 1 by 3. Here this is the V average is equal to 2.5 kilometer plus 2.5 kilometer by T1 is nothing but 1 by 2 hour plus 1 by 3 hour. So that V average is equal to 5 by, here what is the LCM? 6. 2 3 times, 3 2 times. So that V average is equal to 5 into 6 by 3 plus 2, that is the, here 2 into 3, 6. So that here 1 by 2 hour plus 1, that is nothing but by 5. So that the average speed is nothing but 6 kilometer per hour. That is nothing but 6 kilometer per hour. That is nothing but the average speed. The average speed is nothing but total distance by total time taken. So that this is nothing but the average speed. Okay, average velocity is equal to the 0, but average speed is equal to the 6 kmph. Okay, in this way we can do the problem. Next one. A car travels first one-third distance. A car travels first one-third distance with a speed of 10 kmph. Second one-third distance. Okay.
మిర్రరింగ్ పోయిందా? ఇక్కడే అయిపోయింది. పోయింది. స్క్రీన్ మిర్రరింగ్ అంటే మీరు రాసేది అక్కడ రావాలి. పిల్లలు ఎవరు చెప్పట్లేదా చాటింగ్ లో?
చాటింగ్ లో
వీడియో కూడా ఇది ఎంత దూరం నుంచి ఉందండి?
జస్ట్ ఒక ప్రాబ్లం ఉందండి. ఒక ప్రాబ్లం వి యావరేజ్ జస్ట్ ఈ ప్రాబ్లం ఉన్నాయి. ఒక పేజ్ ముందు ఇది సేమ్ ప్రాబ్లం. జస్ట్ ఈ ప్రాబ్లం ఇక్కడ వరకు వచ్చేసి
ఒకసారి మళ్ళీ చెప్పేసేసుకున్నాను.
మళ్ళీ ఇక్కడ వరకు వచ్చింది.
ఇప్పుడు నుంచి చెప్పేసేసుకున్నాను.
ఓకే.
సో ఆ ముందుది ఒకసారి వెళ్ళండి, అదేంటో ఒకసారి జస్ట్ చూపించండి పిల్లలకి. ఇప్పుడు కదులుతున్నాను, ఇప్పుడు స్క్రీన్లో కదులుతున్నాను. పిల్లలకి చెప్పండి, జస్ట్ ఒక నిమిషం ఒక వెయిట్ చెప్పండి.
ఓకే,
ఇక్కడికి ఒక 2 seconds లేట్ అవుతుంది, బట్ ఇక్కడేమున్నది అనేది ఇక్కడే ఉంది.
ఓకే, okay. Dear students, here, no, now okay, board is clear. Okay, now here a ball is dropped from the roof of the tall building. Simultaneously, another ball is thrown horizontally with some velocity from the same roof. Which ball lands the first? Explain your answer. Here, both will reach the ground simultaneously because here, if it is dropped, time is nothing but 2h by g. And, okay, Nana, just. And another one, if it is projected horizontally, then also the time is equal to the 2h by g. So that t1 is equal to the t2. Now we go for the next problem. Here, a man walks on a straight road. From his home to a market 2.5 kilometers from away with a speed of 5 kmph. Find the market is closed. He instantly turns and walks back home with a speed of 7.5 kilometers per hour. What is the average velocity and what is the average speed we want to find? First of all, what is the average velocity? Total displacement by total time taken. That is called the average velocity. Here this is the home and this is nothing but market. Is moving to the home to the market and market to the home, so that total displacement becomes to 0, so that average velocity is 0. Now we go for the average speed. What is the average speed? Average speed is nothing but total distance by total time taken. That is nothing but d1 plus d2 by t1 plus t2. So that here average speed is equal to V average is nothing but d1 plus d2 by t1 plus t2. Here d1 is equal to d2 is equal to what is the value? 2.5 kilometers. d1 is equal, d2 is equal 2.5. Here, what is the distance? That is nothing but 2.5 kilometers. And what about the time? Speed is equal to the distance by time. That implies time is equal to the distance by velocity. So that time t1 is equal d1 by v1. So that velocity equal distance, speed is equal distance by time. Time is nothing but distance by speed. t1 is equal d1 by v1. t1 is nothing but 2.55. Speed, first initial speed is nothing but given that 5 kmph. This is the 5 kmph. So that t1 is nothing but 1 by 2 hour. t1 is nothing but 1 by 2 hour, or t1 is nothing but 30 minutes. t1 is nothing but 30 minutes. And what about the t2? t2 is nothing but d2 by v2. d2 is also same 2.5 kilometer by what is the time taken? That is now what is the velocity or speed? That is nothing but 7.5. 25 3 times. So the t2 is nothing but 1 by 3 hour. That is nothing but t2 is nothing but 20 minutes. Now we go for the average speed. Now we go for the average speed. Therefore, average speed is equal to V average is equal to D1 plus D2 by D1 plus D2. D1 is nothing but 2.5 plus 2.5 by, this is nothing but 1 by 2 here, that the time is nothing but 1 by 2 hour plus 1 by 3 hour. That is equal to 5 by, here 6 is the LCM, 2 3 times, 3 2 times. Therefore, average speed is nothing but 5 by 6. Therefore, average speed is nothing but 6 kmph. What is the average speed? That is nothing but 6 kmph is nothing but the average speed. Okay? This is the average velocity is equal to 0, but average speed is equal to the 6 kmph. Average velocity equal to 0 because total displacement is 0, so that average velocity is 0, average speed is equal to this value. Now we go for the next problem. Here given that a car travels first 1/3 of the distance with a speed of 10 kmph and second 1/3 of the second third at the 20 kmph and last third at the 20 kmph and the last third at 60 km. Here a car travels first third of the distance with a speed of 10 kmph, second third at 20 kmph, last third at here. This is the last third at here. Last third at 60 kmph. Last third at 60. Problem is wrong here. Last third at 60 kmph. What is its mean speed over the entire distance? Here given that total distance is nothing but some S. First 1/3. First 1/3 with a speed of V1 is equal to 10 kmph. Second 1/3 with a speed of V2 is equal to 20 kmph. Last 1/3 with a speed of V3 is equal to 60 kmph. Then what is the average mean speed or average speed? Entire distance, what is the average speed? Here that is the 18 kmph or m. Okay, this is nothing but we want to find average speed or average velocity. Okay, so that here what is the average speed or average velocity? Total displacement by total time taken. Here total S1, S2, S3 values are given, but there are no T1, T2, T3 values. There are no T1, T2, T3 values. So that here we know that velocity is equal to displacement by time. That implies time is nothing but displacement by velocity. So that here average velocity is nothing but S1 plus S2 plus S3 by T1 is nothing but S1 by V1 plus S2 by V2 plus S3 by V3. So that V average is equal to S1 is nothing but S by 3 plus S by 3 plus S by 3 by, here S1 is nothing but S by 3 V1 plus S by 3 V2 plus S by 3 V3. So S by 3 plus S by 3 plus S by 3, V average is nothing but S by, here S by 3 is the common, 1 by V1 plus 1 by V2 plus 1 by V3, 1 by V2 plus 1 by V3. So that here we are writing in the next page. Okay, V average. So that here V average is nothing but S by 3 plus S by 3 plus S by 3, that is S by. Here S by 3 is the common, 1 by V1 plus 1 by V2 plus 1 by V3. Here S and S cancel, so that V average is equal to 1 by 3 into what is the LCM? V1, V2, V3 is nothing but the LCM. Here there is a V1, this is nothing but V2, V3 plus V1, V3 plus there is a V3, so that V1, V2. So that therefore V average is nothing but 3 V1, V2, V3 by V1, V2 plus V2, V3 plus V3, V1. This is nothing but the formula for the average velocity in three intervals. Average velocity in two equal displacement, 2v1 v2 by v1 plus v2. If average velocity in three equal displacements, 3v1 v2 v3 by v1 v2 plus v2 v3 plus v3 v1. Okay, so that therefore average speed or average velocity is nothing but 3 into 10 into 20 into 60 by V1, V2, 200 plus V2, V3, 1200 plus V1, V3, 600. So that this is nothing but 6 2 12, 12 3 36 into this is nothing but 1000 by 18 or 2000. So that 218, and therefore average speed is nothing but 18 kmph. Two equal displacements, 2 v1 v2 by v1 plus v2. Three equal displacement, 3 v1 v2 v3 by v1 v2 plus v2 v3 plus v3 v1. This is the average velocity. So now here from the motion in a straight line, there will be chance of the 4 plus 2, 4 mass question and 2 mass question. 4 mass question may be problem based on this one. S is equal to ut plus half it is the most important one. After that, average velocity problems and 2 mass questions. Okay, Rana? Thank you. Tomorrow we will discuss about the motion in a plane. From the motion in a plane also, there is a chance of the 4 plus 2. 4 plus 2. Okay, Nana. Thank you.